I'm going to work on the practice walkthrough. You have the answers available, but if you want a little more in-depth explanation, feel free to watch this video. Okay, so we want to simplify each expression, and remember, we're combining like terms. So I see that these can be combined, and these can be combined, right? So 6y plus 2y equals 8y, and 8 plus 5 equals 13, so we have 8y plus 13. All right, let me do it a different way with colors. So these two have the a, so we're going to combine that. 5a plus 3a is 8a. And then we can combine these. We have 9 minus 2 is 7. So we're going to combine it to be 7 plus 8a. All right. This one, we see we can combine these r's. So we have 6r plus 2r is 8r, and then we just have that 4. Let's take a look at number 4. So we have 3m plus 5m minus 10 plus 7. So these can be combined to 8m, and these can be combined. So remember, don't forget this negative here, right? Negative 10 plus 7 is negative 3. Let me combine them together. Oh wait, sorry. We're not allowed to combine these terms. I meant put it together in an expression. So we have 8m minus 3. So whenever it's a minus, you have to do, it's really 8m plus negative 3, but that actually just turns into a minus, so this is the way that we want to write it. So if you ever see a negative, instead of a plus that number, it's just going to be 8m minus 3. Okay, let's do 5w. So we have 5w minus 3w. That turns into 2w plus 4 minus 2. And then these two, plus 4 minus 2 is the same thing as 4 minus 2. So we have 2. So we have 2w plus 2. Here, we have these are like terms. So negative 4p plus 6p is going to be positive 2p, right? So then we have 5 plus 2p. Okay, let's look at 7. So we have our a's that we can combine together. So you have 3a plus 5a is 8a. And then we bring the 2b minus 7b. And then we have 2b minus 7b is going to be minus 5b. So now we need to combine these two. Or not combine them, but put them next to each other. 8a minus 5b. Alright, here we have our x's, our y's. We could do them both at the same time. So 3x minus 5x is going to be negative 2x. And then 4y plus y. Remember there's an invisible 1 there, so that's 4 plus 1 is going to be 5y. Okay, here our common is d. So we have 5d. Remember this minus here. 5d minus 8d is going to be negative 3d. And then plus 8. Alright, almost done with this combining like terms. We have, so this is tricky. So this one is only a t. There's no other t, so we can't combine it. The only thing we can combine are these h's. So we have positive 2h, positive 7h, so that becomes positive 9h. And then the rest of it we can't combine. So it's 3t plus 9h minus 5. Alright, here we have 3, so we have these 3 can all be combined. So you could do it all at once, or you could do 2 at a time. So let's do all at once, and then we'll do it the other way. So we have 6d minus 4d plus 2d. So 6d minus 4d is 2d plus 2d is 4d. So we have 4d plus 2 plus 10. And then we can combine these two to 12. So we have 4d plus 12. You also could have done it a little bit slower. We could have broken it down a bit more. Sorry for the weird lighting. So let's go back to the original. 6d plus 2 minus 4d plus 10 plus 2d. You could have just done the d's first, these two. So 6d minus 4d is 2d. And then we bring the rest down. Plus 2, plus 10, plus 2d. And then we could have combined these d's in this step. 4d and then plus 12. So both of them work. You can do it all at once. You can break it up into different steps. Whatever works well for you. And then finally, number 12. These g's can be combined. Remember, there's an invisible 1 right there. And this one has a negative. So 5g minus 1g is 4g minus 9. And that's it. All right, on to the back side. All right, translate to an algebraic expression. Okay, so the quotient, remember quotient is divide of a number d and 4. So d divided by 4. The total of 5 and a number n. So total is like adding, right? So the total of 5 and a number n is just 5 plus n. The difference is subtraction, of a number and 10. So n minus 10. Twice a number increased by 6. So twice a number, let's say that's 2n, and then increase is plus. So it's 2n plus 6. 8 decreased by a number h, so decrease is minus, so 8 decreased by h, 8 minus h. And then the product, remember the product is multiply. The product of a number and 2 increased by that number. Okay, so this is a two-part one. So first let's just deal with the product. So the product of a number and 2, so that's 2n, increased by that number. So increase is plus, and we chose the number, we chose the variable to be n. So it's 2n plus n. Someone was a little trickier, but all in all, not so bad. All right, now we're going to do the word problems. Okay. You buy 4 candy bars at a cost of $p per candy bar. What is the total cost? Okay, so I don't know what p is. I don't know how much the candy bar is, but I know that I bought 4, and I know that they're each p. So the total cost is going to be 4 times p, but we like to write that as 4p. And this makes sense, right? If let's say it was $10, that's crazy expensive. Maybe they're huge candy bars. If I bought 4 candy bars at $10 per candy bar, that would be 40, right? So it would be 4 times the number, so 4 times p. So the tricky thing about these, again, is we're not going to ever know the actual amount, but we have to use variables, we have to use letters to be a substitute, right? So we don't know what p is, but we're going to put in p as a substitute. Okay, donuts cost $2. You buy d amount of donuts. What is the total cost? So we know that each donut is $2, and we're going to buy d donuts. So it's going to be 2 times d, or we like to write it as 2d without that little dot in the middle. All right, there are p people in a Google Meet. 7 people leave. How many people are in the Google Meet? So we started with p people, and then 7 of them left. So we want to be minus 7, right? So if we started with 10, and then 7 people left, we'd have 3. So 10 minus 7, right? But we don't know, so we're just going to say p minus 7. Okay, Bob has 5 pies. He bakes 2 pies every hour. How many pies does he have after 2 hours? So this one's a little trickier, but not so bad. So he already has 5 pies, so we're going to start with 5. And then he's going to make even more, right? So he bakes 2 pies every hour. So we're going to add 2 pies times every hour that he's baking, right? So we're going to do 5 plus 2h, which makes sense because if he baked for 1 hour, he would have made an additional 2 pies plus his 5, right? So 5 plus 2 times h. Okay. Deirdre has 20 friendship bracelets. She gives B bracelets away to friends. How many bracelets does she have left? So she had 20, and she gave some away. So that's going to be a minus. And we don't know how many she gave away, but it says she gave away B. So whatever B is, it's going to be 20 minus B. All right, last one on this side of the paper. Anthony has a dog walking business. He has 12 good reviews and gets 4 more every day. Good for him. How many good reviews does he have after D days? All right, so similar to Bob, he started with some reviews. So he started with 12 reviews and he gets 4 more every day. So after 1 day he gets 4, after 2 days he has 8, after 3 days he has 12. So we're going to do plus 4 times the number of days, or 12 plus 4D. And that's it for that page. Okay, so this backside, the answers aren't posted. This is the wrap up. Okay, so let's summary it all. Simplify the expression. We get our colors out again. We want to combine our like terms. We have 10b plus 2b. We know that's 12b. And then we carry down the rest of it, minus 8 plus 3. We know that minus 8 plus 3 is the same thing as saying minus 5. So we have 12b minus 5. All right, one of those translating problems. Translate to an algebraic expression. We have 12 decreased by a number. So decrease. So we started with 12 and we lost some mystery number. 12 minus n. Okay, write an algebraic expression to represent the perimeter of the following. So remember, perimeter is like the fence, right? So it's everything around it, right? Area is inside, perimeter is outside. So if we want to find the perimeter, we need to add these things all up. So write an algebraic expression for the perimeter. So this one we're going to add this side, 4, plus this side, 2x, plus this side. And then we can combine like terms. So we get 9 plus 2x. Okay, here's this fence. We're going to start with this side. We're going to add this side. And then finally we're going to add this side. Right? Now we got to combine like terms. This turns into 3x plus 2x is 5x. 3 plus 8 is 11. And then these two we can't combine them, so we just put them next to each other. All right, this one has one more side, but it's not that bad. So we start with this side, 4. We're going to add this side, 2x minus 1. We're going to add this side. And then finally, we're going to add the top side of the fence of our perimeter. All right, this one's a little tricky because it has a minus, but not so bad. So let's start with our like terms. We have 2x plus 2x. That becomes 4x. So we have 4 plus 4x minus 1 plus 5 plus 6. Lots of numbers. And then we can just combine the rest of these together, right? The x's. We could do it all together, or we could break it up. Let's break it up. So 4 minus 1 is 3. 5 plus 6 is 11. So we have 3 plus 4x plus 11. And then finally, these two can become 14. So we have 14 plus 4x. So it's a longer one, but the same concepts, right? All right, our exit ticket. Which of the following expressions correctly models the situation? Ray has $8. He buys C candy bars that cost 75 cents each. How much money does Ray have left? So he started with 8, and he bought stuff. So we need the minus. So we already know that it's not A or B because it has a plus, and we want a minus. And then actually, we can see right away that it's C because it's not 8C, it's 8. Well, let's finish the whole thing. So we know that he bought C candy bars, and they were 75 cents each. So he started with 8, he lost this quantity, and we can rewrite that as 8. We can put the number in front, 0.75C, and that matches number C. So hopefully not so bad. Hopefully that explains some of them. And if you always want to, you can go back and try the problems again. And it'll be good practice, and you'll get it down really well. All right.